Now the next important technique is discounting. In discounting, what we are given is future value and what we need to find out is present value. So suppose I tell you, I will give you 1000 rupees after 1 year and you are supposed to find out what is the present value of this 1000 after 1 year. Or let us say you are supposed to receive 5000 rupees after 5 years. What is its present value? So what technique of time value of money we will use? It is called as time value of money. If I draw a simple timeline, year zero means present or today. And let us say I give you rupees 1000 after 5 years. Now what you are supposed to do is this is future value and you are supposed to find out its present value today. So this process is called as discounting. Now here there is only one single amount, 1000 after 5 years, and you are finding its present value. Similarly, you can also have a situation where you are receiving, let us say at the end of year 1, at the end of year 2, at the end of year 3, 4 and 5 so on, 1000 at the end of every year, and you are supposed to find out its present value in year 0 or present or today. So you will have to find out present value of each of these amounts and then make a total of all the present value, which is called as sum. So sum of present value of all future values is also called as, this is present value of annuity. Since you are receiving 1000 rupees every year, this is annuity. And this process of bringing future values to present is known as discounting or finding present value. Now for this you require two tables here. One is table C from the PDF attached. If you see the title of table C, it is present value of a lump sum of rupee 1. Lump sum means one single amount, right? It is also called as PVIF at R percentage for n years, which simply means present value interest factor at R percentage for n years. So when do you use PVIF or table C? When you have one single future value and you have to find out its present value, but one single amount. Okay. Then you have table D. Table D is called as present value of an annuity of rupee 1. Okay. So annuity means same amount every year. So we call it as PVIFA at R percentage for n years. This is present value interest factor of annuity at R percentage for n years. Right? So when do we use this? When you have to convert annuity factors which are received in future or annuity amounts in future to present value. So basically it is future value of annuity into present value. Okay, we will see with the help of examples. Okay. See example number, this example. Okay. Example number 5. You are supposed to get rupees 1 lakh after 1 year. What is the present value if interest rate is 10%? So 1 lakh after 1 years, it means in future you are going to get rupees 1 lakh. So 1 lakh is future value. Interest or R is 10%. We also call this as 0.10. So what will be the value of 1 lakh you will receive after 1 year today? So basically you have to find out is present value. Formula for present value is future value upon 1 plus R raised to N is equal to 1 lakh divided by 1 plus R is 1 plus 0.10 raised to 1 is equal to 0.90900. Okay, approximately. Now, if you want to use tables, so what you will do is instead of formula, what you can do is future value into PVIF at 10 percentage for 1 year. Okay, so future value is 1 lakh. PVIF. Now see, this is only one single amount, so you will see table C. See table C, 10% and 1 year, you will get the factor 0.909 and multiply 1 lakh with 909, you will get 90,900. So you can use formula, you can use table. Table is more simpler. We will move ahead with tables only. You are also asked to find out your answer if you receive 1 lakh rupees after 3 years. So present value in this case, if n is equal to 3 years, would be future value into PVIF at 10% for 3 years is equal to 1 lakh into, now see table C, 10% and 3 years. Okay, so you will get factor of 0.751 is equal to rupees 75,100. Okay, so you see, as the n increases, okay, the present value also reduces. Okay, because the more you delay payments in future, the more it becomes risky and the present value declines. Okay, this is simple present value of one single amount. This is lump sum. Lump sum means you are receiving amount only once. Okay. Now see example number 6, where you are receiving different amounts at different time period. So suppose you will receive 1 lakh at the end of year 1, 50,000 at the end of year 2, 30,000 at the end of year 3. Discounting rate or R is equal to 10%. What is the future present value of future cash flow? So since you are receiving different cash periods at different time periods, what you have to do is you have to find out present value of each cash flow and then make a total. So basically what you have to do is present value is nothing but I am writing sum of present value of all future cash flows. Okay, simple language. Sum of present value of all future cash flows. So you are receiving 1 lakh at the end of year 1. So 1 lakh will be multiplied by PVIF at 10% because NR is 10% and this is at the end of year 1. So N is year 1 plus. What is the second future value or second cash flow? It is 50,000 into PVIF at 10% for year 2 because this is cash flow of year 2 plus 30,000 into PVIF at 10% for year 3. This is cash flow of year 3. Simply check table C, 1 lakh into table C, 10% and 1 year. You will get factor of 0.909 50,000 into 10% and 2 years, so 0.826. And third is 30,000 into 0.751. 10,000 and 10% and 3 years in table C. Now just solve this and you will get a grand total of 1,54,730. So this is nothing but sum of or total of all the future values at their present values. Okay. This was discounting when there is either a single amount or series of single amounts. Now let us say there is an annuity. What does annuity mean? It means you are receiving same amount every year for certain period of time. Okay. Now there are two types of annuity. The first type is annuity ordinary. Ordinary means when you receive amount at the end of year. Okay. Now see, present value of annuity. I am writing the formula, but you don't have to worry about the formula because ultimately we will be using tables. Is equal to A into 1 minus 1 upon 1 plus R raised to N upon R. Okay. This is a formula, but you don't have to remember this formula. What you can simply write in exam is A into, this is annuity, so we will use annuity factor. Present value interest factor of annuity at R percentage for N years. You have to remember only this much in exam. Okay. Now see the example. You are going to receive 1,000 rupees. So annuity is 1,000 PVIFA. Interest rate is 10% and N is 5 years. So interest rate at 10% for 5 years. Now you will check table D because table D is related to annuity. So 1,000 into, check table D, PVIFA, 10% and 5 years. The factor is 3.791. It is rupees 3791. This is the present value of 1,000 rupees every year for next 5 years. But its present value is 3791. Okay. Now another type of annuity is annuity due. Annuity due means when you receive the amount at the start of the year or at the beginning of the year. Okay. So Mr. A has started receiving money at the beginning of each year, 4 years, and 10% interest, and 10,000 each year. Each year means annuity. So A is equal to rupees 10,000. R is equal to rate of interest is 10% or 0.10. 0.10 or 10%. N is equal to 4 years. Okay, I am writing the formula. You don't have to worry about the formula. Present value of annuity is equal to A into 1 minus 1 upon 1 plus R raised to N upon R. Instead of formula, what you can write is this is annuity due. So you have to multiply this with 1 plus R. So A into PVIFA at 10% for 4 years multiplied by 1 plus R. Now let us substitute. A is equal to 10,000 PVIFA. See table D. 10% and 4 years, you will get the factor, annuity factor 3.170, and 1 plus R is 1.10. Now solve this, you will get answer rupees 34,870. Okay, this is present value of annuity due. Okay, so present value of annuity due means you are getting amount at the beginning of the year or starting of the year. Extra thing that you have to do is you have to just multiply the formula with 1 plus R. Okay, so A into PVIFA into 1 plus R. If it is annuity ordinary, like in previous example, you simply write A into PVIFA. When it is annuity due, you multiply it with 1 plus R. Now there is a concept called as perpetuity. Perpetuity means when your N is infinite. Suppose your cash flows do not have any life. It is there till N years, and we don't know N. We cannot define N, infinite years. Okay, because firms are going concern, and some firm promise that till we exist, we will keep on giving you, let us say, dividend of rupees X for infinite years. Now, how do you find out the value of those dividends? Okay, so let us do one application of perpetuity. Mr. Sriram wants to start a scholarship that pays 25,000 to students for outstanding performance at Sriram College of Commerce. He wants to know how much he can invest at 12.5%. Now, you want to create a fund. The interest rate is 12.5%. Now, out of this interest, you want to pay 25,000 to student as scholarship. Now, number of years is not mentioned. It means this is an example of perpetuity. So, present value of perpetuity का मतलब होता है same amount till infinite years is equal to A, that is annual amount, upon R, that is rate of interest. So you want to pay 25,000 rupees every year for infinite years at the rate of interest of 12.5 percentage or 0.125. This comes out to be rupees 2 lakh. This means Mr. Sriram has to make a fund of rupees 2 lakh and invest it at a place where he gets 12.5% interest. And from 12.5% interest, he can pay scholarship of 25,000 rupees every year. Okay. Now, perpetuity with growth. This is also called as growing perpetuity. Let us read the example first. Mr. Sriram wants to start a scholarship of 25,000 for outstanding performance. This is important. However, he wants scholarship to grow at 5% every year to offset inflation. Now, since there would be inflation, you cannot keep on giving 25,000 every year. He wants 25,000 to increase by 5% every year. How much he can invest at 12.5% to pay the scholarship for perpetuity? Since he wants scholarship or annuity to grow, this is called as growing perpetuity. The formula is present value of growing perpetuity is equal to A upon R minus G. A is equal to first scholarship of 25,000, R is 0.125, and G is 5%. 5% is the growth rate. So 25,000 divided by 0.075, your answer would be 3,33,333. So if you invest 3,33,333 at an interest rate of 12.5% per annum, you will be able to give 25,000 plus growth rate every year for infinite years. This is the logic of it. This is growing perpetuity.